Okay, so hi everyone, welcome to Sec 4 Math with me, Teacher Kim, on Thursdays at 8 p.m. I hope you guys are having a good Christmas week, enjoying your Christmas holidays, and of course, yeah, staying safe. Yes. Okay, so please, those of you who just logged in, please make sure that you are logged in through the proper channels, okay, so that you can take part in the bubble questions we have for you today, and also, more importantly, okay, so that I can see your messages in the chat when you send them in. Okay, yeah, and please make sure to have some writing materials with you, your calculator. You will definitely need your calculator today, for today's lesson at least. Okay, so please make sure you have all those math materials with you. Okay, so general rules as usual. Please remember to be patient and understanding. Always remember to observe gracious and respectful behavior. And of course, don't be afraid to ask any good and relevant questions. Okay, if I cannot answer your questions during the lesson itself, not to worry. I will stay back for 5 to 10 minutes at the end. Okay, so that's when you can ask me any additional questions you might have or anything that's out of syllabus and things like that. Okay, or especially if you want me to go back to a certain slide for you to take down notes, that's the time we will do that as well. Okay? Okay, so probability of combined events. So that is what we will be doing today. So I understand that you guys did a bit of probability in Sec 2. Yeah, but we will be building up on that, okay, to do more complex probability questions, of course. Okay, so first we will recap the Sec 2 probability. Okay, so what is probability? How do we calculate it? How do we calculate simple probability? And then we will build up on that with possibility diagrams, tree diagrams, and then combine probability with and without replacement. Okay, so we will see the difference between the two. Okay, so sample space and outcomes. Okay, so recap from Sec 2, we learned about sample space, right? So sample space is all the possible results we can get. Okay, so when I toss a coin, what are all the possible results I can get? I can either get heads or I can get tails. Okay, so my sample space when flipping a coin is either heads or tails. Okay, I'll write it out. Okay, and what are the number? How many possible outcomes altogether? 2, right? Heads or tails, that's 2. Okay, rolling a dice. Okay, so what are the possible outcomes I can get? So when I roll a dice, what are the possible values I can get? I can get either 1, 2, 3, 4, 5, or 6. Okay, so altogether I have 6 possible outcomes. Pretty simple, pretty straightforward, right? So this is from Sec 2. And how do we calculate simple probability? So when you have a single event, so, okay, if you have a total number, okay, of m likely outcomes, so altogether there are m outcomes, and k of those outcomes are the ones that you want, okay, then the probability is simply k over m. Following? Yes? Okay, this is from Sec 2, yeah? Okay, so probability of a single event. Let's watch the video, okay, to give you guys an example. Okay, so over here we have a box of bubbles. We have 5 red, 7 blue, and 8 green, right? Okay, so all together, how many bubbles do we have? All together, we have 20 bubbles. Okay, so if I take one, okay, what's the chance that the one that I take out is red? So of all the 20 balls, only 5 of them are red, right? So I get probability. So the probability of me drawing a red ball will be 5 out of 20. Okay, and of course, we always need to simplify. Any questions here? Okay, so to repeat again, this time with blue. Okay, so To draw a blue, the chance of me drawing a blue bubble is I have 7 blue, so it'll be 7 out of 20. And of course, for green, I have 8 green balls, so it'll be 8 over 20. Okay? Then I simplify to get 2 over 5. Any questions? Okay, so probability of probability of any event. Okay, so the probability, if the probability calculated is between the values 0 and 1, so not equal to 0 and not equal to 1. Okay, hi Shayna. Hi Denise. Possible, so it's possible that you understand. Oh, you mean you're filling in the blank. Thank you, Denise. Okay, so the first one, yes. Okay, so if the probability of an event is between 0 and 1, so not equal to 0 and also not equal to 1, then E is known as a possible event. Okay, possible because it might or might not happen. Okay, but if it is 0, okay, if the probability is 0, means it is impossible. Okay, means there is no way it will happen. Okay, and of course, if the probability is equal to 1, then that means that it is a certain event. Means it will definitely 100% happen. Okay, any questions? Okay, no questions, then let's do a worked example. So a fair die is rolled. Find the probability that the number shown is even. Okay, so first let me list my sample space. So I have 1, 2, 3, 4, 5, 6, right? This is my sample space. Okay, these are all the possible results I could get when I roll a dice. So I only want the even numbers. So I have even numbers 2, 4, and 6. Okay, so that means for part A, the probability, okay, of me rolling an even number, I have 3 possible outcomes out of a total of, very good Sherilyn, out of a total of 6 outcomes. Okay, so that is why, okay, so I break it down. This is 3 even numbers. And this is 6 numbers altogether. Okay, so when I simplify, the probability of me getting an even number will be simply half. Okay, part B, not a factor of 6. So keyword not a factor of 6. So what numbers here are not factors of 6? We have the numbers 4 and 5, right? Okay, so the probability of me rolling a number that is not a factor of 6 will be 2 out of 6. Okay, so that will give me 1/3. Any questions here? Yeah, so I just write this just to make it known that it's a capital letter. Okay, it's not IP. It's because okay, so when you, the Roman letter P, okay, I just indicate it like that because it's um it's a personal preference thing. Of course, in schools, most teachers just use the capital P, okay? But I prefer to write it like that just to remind myself that it's a symbol and not. Because sometimes, I don't know, especially with my handwriting, sometimes if I just put P, I might mistake it for a number. Okay, so this is not what you guys need to do at all. Okay, P prime. Why P prime? Okay, because I put the Roman P, because actually if you look at the origin of probability, it was originally symboled using the Roman letter P. But of course, for simplicity's sake, a lot of schools just, yeah, just put the capital letter P. Okay, but if your school is okay with you writing P prime and things like that, then yeah, then that's fine as well. Okay? But of course, Cambridge, if you talk about Cambridge, they have simplified it to just the capital letter P. Okay? Can? But everyone okay with the computation? Okay, the main thing is the computation. I don't want to focus too much on the letter P. Yes. Okay. Okay, very good. Okay, well done. Okay, so let's move on. Let's add on a little bit more of our math concept. Okay, so what is the possible outcomes of rolling a fair die? We already know. Okay, it's all the numbers. 1, 2, 3, oops. 1, 2, 3, 4, 5, 6. Right? Okay, so this is something similar to a possibility diagram, okay, where we list out. So you realize what we did here was we listed out all the outcomes, right? So this is something like what we do in a possibility diagram. Okay, so we will list out all the possible outcomes. So how do we list? Okay, we use a chart like this, like a table. Okay, so in our first die, okay, so sometimes some schools have a header here. Okay, so first die, and this is your second die. Okay, but some schools are fine even if you don't put any headers. Okay, so in this case, there's no space for headers, so I'll just take it away. Okay, so what are the chances? What are the possible outcomes that I can get? So I can roll my first die and get a 1, and then roll my second die and also get a 1, right? Or I can roll my first die and get 1, and then on my second die, I get 2. Okay? And then, or I can get 1 and then 3, 1 and then 4. Okay? Or I can get 2 and then 1, 2 and then 2, 3 and 1, 4 and then 1, so on and so forth. Do you guys get the pattern here? Okay, so this is what we do in a possibility diagram. Okay, so the key thing about a possibility diagram is that we list all the possible outcomes. Okay, so that is the purpose of the possibility diagrams. Okay, so something like that. In the end, when you fill in the entire table, this is what you get. For the second box on the right of the printed numbers, can write 2, 2 instead of 1, 2. Okay, so usually we go by row and then column. But don't have to rule out the same outcomes, 2, 5, 5, 2. Yeah, so you will have 5, 2. Okay, hi Isabel. So you will have 5, 2 here. Okay, so you will have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So on and so forth. Does the permutation matter? No. Okay, but of course, it pays to be neat, because if you're jumbling everything everywhere, sometimes, of course, you might miss out some numbers. Okay, if you do 1, 1, and then you do 2, 3, and then 2, 4, and then 4, 5, sometimes, okay, when you, especially for the marker, they might get a bit annoyed, okay, because it's very hard to check whether you have listed everything. Okay, and also for your sake, because you will use this, okay, you will realize later in the next slide, okay, that we will actually use this in our calculation. So it's important that you make it easy to read, okay, and easy to look for. Okay, because if you have numbers all over the place, later on when you refer to this table for your calculations, you might miss out certain squares, okay, that you actually need. Okay, that's why we always try to keep it neat and keep it to a fixed pattern, so that when you need to look for numbers, then it's easier. Okay, so what are the possible outcomes of rolling 2 fair die? Okay, so the possibility diagram was drawn. Okay, So how do we use it in our computation? Okay, so two fair die are rolled. Find the probability that both die show odd numbers. Okay, so we want an odd number on our first die. So that means 1, 3, and 6. And then we want odd numbers on our second die as well. So 1, 3. Oh, 1, 3, 5. Ayo, what happened to me? Sorry. 1, 3, 5. Okay, so which are the outcomes we want? We want 1, 1. We want, okay, maybe I'll do it in green as well so it's not so confusing. Okay, so we want the outcome 1, 1, right? Where we roll a 1 and then the second dice also get 1. Okay, and then we also want 1, 3, 1, 5. 3, 1, 3, 3, 3, 5. 5, 1, 5, 3, 5, 5. Everyone okay with this? Okay, so for part A, so after you draw your possibility diagram, you will use it in your calculation. Okay, never mind. For you guys, I'll just put a capital P. So P, both odd, okay, will equal to, so how many outcomes do I want? I want 1, 2, 3, 4, 5, 6, 7, 8, 9 outcomes. Okay, so I have 9 favorable outcomes out of a total of 6 by 6, which is 36 outcomes. Okay, so then I simplify and I get 1 out of 4. Okay, do you see why it pays to be neat? Hi, Sherilyn. Will the possibility diagrams be marked during the exams? Yes. Okay, so possibility diagrams are worth anything from 1 to 2 marks. Rarely ever 3 marks, but I wouldn't rule it out. Okay, hi Denise. Will the table be given in exams? No, you are required to draw them. Okay, so that's why I keep highlighting that it pays to be neat. Okay, hi Isabel. Oh my god. Denise also sent a sad face. No. Okay, think of it as free marks. I mean, you're given marks to just draw a table and draw X's. Isn't it good? Okay. So hi Sherilyn, must we list all the possible outcomes or can we just mark it with an X? So this varies from question to question. So usually if it is a bit long, okay, then you can generally Cambridge will just close one eye if you put X's. But of course the best proper way, okay, is to list out everything. Okay. No, oh my god, Denise had a really long, like, sad face. Sherilyn also crying face. Okay, no more tears. It's Christmas week, okay? Okay, part B. Let's do part B. Okay, so the number shown, the probability. Okay, so now we want to find the probability that the number shown by one of the die is 3. And the number shown on the other die is not 3. Okay, so if 1 is 3, then the other one cannot be 3. So it must be like this, right? Or if 1 is 3, then not 3. Do you see? Why? You must go both ways, okay? So it's either our first die. So if this is my first, okay, so that's why it helps to label. So first and second. So if my first die is 3, then my second die cannot be 3, right? So I'll take 1, 3, 1, 3, 2, 3, 4, 3, 5, 3, 6. Okay, or if my second die is 3, then I'll have 1, 3, 2, 3, 4, 3, 5, 3, 6, 3. Okay, so all together I have how many outcomes that I want? Okay, all together that will be, okay, only, so the probability that only one is 3 It's 10 out of 36. Okay, very good, Denise. Well done, okay? Yeah, so then from here, I simplify and I get 5 out of 18. Okay, do you see why it's so important to be neat? I keep highlighting, okay? Neat, neat. Okay, some students, oh my goodness, their possibility diagrams, you don't even know where the x is. Like this is 1, 2, 3, 4, 5, and then their axis is like that. How to see? Okay, so please be neat. Okay, make sure the marker, not just you can read, but the marker can read as well. Okay, and so that you can also refer to it when you're doing your calculations. Yes? Yeah, okay. No questions? Bubble question 1. Okay, so 2 fair die are thrown one after the other. So find the probability that both dice show different odd numbers. Okay, so okay. I think there was a printing error. Okay, not sure why. It shows that there was a possibility diagram drawn, but it's not on the screen, but it's okay. I will do it here for you. Okay, so we have one dice with 1, 2, 3, 4, 5, 6. We have another dice, 1, 2, 3, 4, 5, 6. Okay, so then you draw. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, you guys get the idea, right? Okay, I'll start the 2 minutes now. Okay, so try drawing the possibility diagram on your own as well. Okay, so draw it on your piece of paper, and then and your 2 minutes starts now. Okay, so complete this. Okay, maybe I'll do this. Ooh, okay, so my diagram is also not that perfect. Okay, so what are the results we want? Remember, we want the probability that both show different odd numbers. Okay? So if we get a 1 on our first die, then the second one cannot be a 1. It can be a 3 or a 5. Okay? And then if we roll a 3 on our first die, then we can get either a 1 or a 5 on our second one. We roll 5 the first time, we can get 1 or 3. Okay? Then you do the other way as well. So you check the other direction, and once you've done that, then you can count, okay, the number of favorable outcomes you have. Okay? Then simplify your probability. Okay, time's up. Let's take a look. Okay, so who struggled with this question? Does anyone have any questions on why? Okay, so any questions on why I highlighted those boxes? Hi, Lucas. It's easy. Okay, that's good. That's good for you. Okay, but what about the rest? Is everyone okay with this? Okay, so everyone understand why I only highlighted those boxes? Okay, so means that those favorable outcomes, of all the outcomes, I only have 6 favorable outcomes, right? Okay, and total I have 36 outcomes. Okay, so it will be 6 out of 36, and of course I simplify this, okay, to get 1 out of 6. Okay, any questions on a possibility diagram? Okay, so the key thing I want you guys to understand about a possibility diagram, okay, is to not just list, okay, so possibility diagram, we list all the possible outcomes, then we add, okay, favorable outcomes together. We count how many favorable outcomes we have. Okay? So now we will compare this to a tree diagram. So let's think about it again. What are the possible outcomes of tossing one fair coin? Okay, so what are the outcomes we can get? Okay, what are the results we can get when we throw a coin? Okay, again, I've said this before, right? Okay, we can either get heads or we can get tails. Okay, and what's the chance of us getting a head? Okay, what's the chance of us throwing a coin and then it showing head? It's 1 out of 2. Same for the probability of tails. Very good, Perka. Well done, Ananya. Okay, yes, half. Okay, what if we throw 2 coins? Okay, so first coin, so I have my first coin, then I have my second coin. So my first coin, my outcomes are either head or tails, right? So when I throw my first coin, I can either get head, with a probability of half, or tail with also a probability of half. Then when I throw my second coin, let's say I threw a head on the first coin. Okay, the first coin showed me heads. Then my second coin can also either show me heads or tails, right? Everyone clear with this? And the probability is still half and half, right? The probability does not change. Okay, so even if I threw my first coin gave me tails, my second coin, I can still get either heads or tails. Okay, and the probability doesn't change as well. Okay, so what is the chance of getting throwing heads twice? So if I want heads, then I have probability of half, right? And then the second time, I also want heads. So it'll be half and half. Okay, so this is what we call a tree diagram. So for a tree diagram, instead of listing, remember possibility diagram, you had to list everything out. Okay, for a tree diagram, you draw branches. Okay, do you see everything branches out? And the key thing is that you multiply, okay, along the branches. So previous one for possibility is you add, right? You count 1, 2, 3, 4, how many outcomes you want. Okay, for this one, you multiply along the branches. Okay, so let's say we want the probability of head and head. Okay, so that will be half times half. Okay. Why multiply? Okay, Denise. So I know you like to ask this kind of out of syllabus questions. Okay, so I will put that at the end of the class. Okay, so we will spend time on why later. Okay, but for now, I just need to focus, okay, because we still have quite a few slides to go. Okay, so I will just focus on the syllabus, what is within the syllabus first. Okay, but everyone understand, okay, the difference between a possibility diagram and a tree diagram? Is that clear? Yes? Yes, yes, no, yes. Anyone need to clarify anything? Hi, Sherilyn. Which part? Which part is not clear? The entire tree diagram. Okay, so, okay, do you understand where, okay, maybe we look at the simpler example first. How about this one? Okay, when we toss one coin, Okay? Okay, so you understand this. When we toss one coin, the sample space is head or tails, right? So we have two possible outcomes. Okay, two possible outcomes. So two branches. Okay, so we have two branches, one branch for head and one branch for tail. And for the second one, okay, so this part, you get it, right? This first coin. The first coin is good. Okay, second coin. Okay, so now, okay, let's cover this. Let's see if I can do this. If I cover this, okay, let's hope I can erase that. So now I'm assuming that my first coin that I threw showed head. Okay, so when I throw my second coin, okay, so when I threw my first coin, it showed me head. Okay, now I have a second coin, I throw it. What are the possible outcomes? So I have my first coin, it's already stuck, it's on head. But when I throw my second coin, what are the outcomes I can get? Again, I can get either head or tail. So it's two different outcomes. So again, two branches. Okay? Yes? Yeah. No. It's two different coins. Okay? So one coin, first coin, second coin. First coin I throw, I get head. Okay? Then I keep it. So this is head now. Now I take my second one and I throw it. So what are the outcomes I can get when I throw this second one? Okay, so the second one, okay, Denise, is the second coin. You can think of it as a second coin. Okay, Charlene, so the first branch on the left is for the first coin and the second branch on the right is for the second coin. Yes, very good. Okay, which is why I have this header here. Okay, which is why we have this header first and then we have second. So this section is for second. You see? Yeah? Is this clearer? Yeah, okay, very good. Okay, so again, tree diagrams. Okay, so possibility diagrams, just now I said the marks. For drawing a possibility diagram is anything from 1 to 2 marks, right? For a tree diagram, it is a lot more. Okay, so it can range for anything from 3 to 6 marks. Okay, if you look at your TYS, because tree diagrams, you will realize is a lot of details, right? Possibility diagrams are a bit simpler because it's just listing everything out like 1, 2, 3, 4, 5, 6, and then you cross, and then you plus. Okay, but for this one, okay, you will realize you need to, okay, so a lot of students, firstly, they forget the header. So you get 1 mark for header, second mark for listing all the probabilities. Okay, so depending on how many branches you have, of course, okay, you also need to write out the probabilities on each of those branches. And then, of course, you need to consider the correct outcomes. Okay? Yeah, I'm sure you guys can do it. Come on. Okay, Isabel, those must be complicated. No, it's the same. It's the same. You cannot think of it that way. Okay, but is everyone clear with a tree diagram? Yes? Yes? Yeah, okay, very good. Okay, so what are the possible outcomes for throwing 3 flat coins? So of course we can keep doing this, right? We have 1 coin, 2 coins, 3 coins, 4 coins. So if we have 3, it'll just look something like that. So head, tails, okay, this is my first. And then I have this, head, tail, okay, this is second, or head, tail. And then my third, again, it's either head or tails, head or tails, head or tails, head or tails. Okay, everyone, of course I did this really quickly without the proper labels, but okay, this is the general idea. Okay, so we have the first coin, we can throw either heads or tails. So if we get the first one head, then the second one can either be head or tails again, right? And then the second one is head. The third one can also either be head or tails, right? So this just keeps building and extending on and on and on. Okay, any questions? Okay, this is very, very important, yeah? Okay, so 3 fair coins are tossed. Display all the possible outcomes using a tree diagram. Okay, so now I need to draw. Okay, I'll do it in black. Okay, so I have first coin, second, and third. Okay, so I'll work backwards since I already did a sketch. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 outcomes for my third. 2, 3, 4, 5, 6, 7, 8. Okay. Oops. Ooh, what happened? What is this? How do I close this? Oh gosh, okay. There we go. Ah! Okay, so sorry for that. Okay, everyone clear with this? A possibility diagram? Tree diagram, sorry. Okay, then head. Give me heads or tails. Head or tails. Okay, so this is my tree diagram, and of course don't forget you need to write out the probability. So half, half, half. Okay, of course if the probability is not half, then you will have to write it accordingly as well lah, huh? Okay, so you write the appropriate probability on the branch itself. Okay, then part B. Okay, so this is part A. Part B, part 1. Find the probability that the second coin shows head. Okay, probability. Second coin is heads. Okay, so what are the paths? Okay, so you can think of it as paths or branches. Okay, so we want second coin to show head. So second coin is here, head is here. Okay, so what are the possible paths we can take? We can take from here, then we go here. Okay, then we must always finish. Okay, must always go from one end to the other end. You cannot just stop. You cannot just stop here. Okay, you need to go all the way to the end. Okay, so that's one path. Okay, so I'll put a yellow tick. So that's 1. And then we have a second one here. So 1, 2, 3. 3 steps again. Right? So that's our second option. Or we have 1, 2, 3. And 1, 2, 3. Okay, so all together we have 4 paths. Okay, so we have 4 out of 4 paths, and then remember for a tree diagram, we are not adding, right? For a tree diagram, what do we need to do? We need to multiply along the branches. Okay? Oops. Okay, so to multiply along the branches, we realize each branch is the same, right? Half times half times half. Okay, so half times half times half. Okay, so then we will just calculate this. So 1 over 8, 4 times 1 over 8, which will equal to half. Yes? Okay, and for B part 2, at least one of the coins, one of the coins shows tails. Okay, so it can be anything as long as it can be anything except except all hits, right? Do we realize? Because it can be, okay, because it can be hit, hit, tails, hit, tails, hit, then tails, hit, hit, or we can have hit, tails, tails, so on and so forth. It's quite a lot, right? It's everything except hit, hit, hit. Okay, so we can do the reverse where we do 1 minus the probability of all hits. Hi Vivia. Yes, okay, so for part A, you added and got half. Does it depend on the question? Yes, okay, because this question, you can add because you realize the probabilities are all the same. But the moment you have questions that differ in probability, okay, as you will see later on, then you can no longer add. Okay, you must definitely multiply. Okay? Okay, but everyone able to follow so far? Any questions? Okay, so to find the probability of all hit, it's here, right? So we must get hit on our first one, hits on the second, and hits on the third. Okay, so to do that, we take half times half times half. Okay, so 1 minus 1 over 8, that will give us 7 out of 8. Okay, anyone confused? Any questions? Hi, Charlene. Oh no. Okay, which part? Which part? B part 2. Okay, confused with B part 2. Okay, so at least, okay, do you understand this part where I listed all the outcomes? Okay, because if you list out everything, okay, so you can try it on your own. Okay, so if I want at least one hit, right? This means that I can have either one hit or I can have 2 hit. Eh? Oh, tails. Sorry. At least one tail. At least one tail. So I can either have one tail or 2 tails or I get all 3 tails, right? Because that's at least. Can we agree on this? This part, okay? Okay, so if I look at the at the outcomes where I have one tail. Okay, so I look at the outcomes where I have one tail. That will give me hit, tails. Hit, tails, hit, or tails, hit. So I get 3 outcomes. Yes? Then if I do 2 tails, I get hit, tails, 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 hit, tails, or tails, tails, hit. Okay? And for, okay, I'll just do green. Okay, for 3 tails, it's definitely tails, tails, tails. So if you look at all the paths we have, right, one way to examine it, hit, tails is over here. Okay, I'll do it in black. Hit, tails is over hit, tails. Okay, so that's here. And then hit, tails, hit over here. Then tails, hit over here. So if you keep crossing out all the different paths, you will realize you essentially cover all the paths except for one. Okay? All except the one where it gives you hits. Okay? So you can try it on your own. Give yourself a few minutes, okay, to try it. Can? Anyone has any other questions? Anyone else needs to clarify anything? Okay, so if no questions, then bubble question 2. Okay, so again, you can draw your own tree diagram. Okay, I encourage you guys to try drawing your tree diagram on your own. Yeah, and you have 2 minutes. Okay, so draw your tree diagram and then calculate the probability. Okay, so 2 minutes, your time starts now. Okay, let me just take a look. Okay, we still have quite a bit. So is it okay if I go a bit faster for the next few? Is this pace okay for everyone? Because we only have like 15 minutes remaining. Okay. Okay, so draw your tree diagram. Okay, I'll just do a sketch. So first, second, I always like to start with my headers first. Okay, and always give yourself more space for your first coin because you realize it spreads out. Okay, so now that you have your tree diagram, okay, remember to fill in the probability. Okay, then you want the probability that exactly one coin shows head. Okay, so if it is your first coin that shows head, then the other two must be tails and tails. Okay, so that's an example of one path that we will accept. Okay, the other one will be tails, tails, head, and then tails, right? Or tails, tails, and then head. Okay, so there are 3 paths, and how would you calculate the probability? Okay, very well done. Anyone has any questions? Exactly 1 H. Okay, so basically the second coin can toss twice, then the third coin toss thrice. No. Okay, Denise, we're only throwing each coin once. Okay? Why first I throw head, the next coin must be head? No. Okay. Hi, Fion. Okay, so Denise, okay, let's go one question at a time. We have 3 coins, okay? And we are throwing each coin once. Okay, so maybe I redraw my, can I? Okay, so let me, okay, can I erase it now? Yes. Okay, so let me redo it in a different way. Okay, so let's say I throw my first coin. Maybe I do it this way. I throw my first coin, I get head, right? Okay, then I throw my second coin. I can either, when I throw my second coin, I can get 2 options, either heads or tails. Okay, everyone understand this part, right? Okay, Denise, is this okay? Okay, then now I ignore this part first. Okay, so let's say I already know the results of my first coin. So my first coin, I know the result is head. When I threw my second coin, my result is also head. So when I throw my third coin, what are my options? My options are head or tails. Yes. Okay, so I'm only throwing each coin once. Okay, so this is one of the possible outcomes. Do you see? So it could be that when I throw my first coin, I get hit. Then when I throw my second coin, I get hit. And then when I throw, okay, so let's say Monday. On Monday, I take my 3 coins and I throw it. then I could get head and head and head, right? Or on Tuesday when I throw my first coin, I get head again. But when I throw my second coin, okay, or when I throw my second coin, I get head again. But this time on Tuesday, when I throw my third coin, I get tails. Right? So this is another possibility. Do you see? Okay, let me remove the circles. Okay? Is this okay? How do you know the second result is head or tail? Hi, Fion. We don't know the result, which is why we need to write out everything, right? We could either, right, on Monday, when I throw my 3 coins, I get head and then head and then head. Then on Tuesday, when I throw, I get head and then tails. Then on Wednesday, when I throw, I can get a different thing, right? Or Thursday, when I throw, I could also get something different. Okay, so what I'm doing is I'm just listing all the different things that I could get. Okay? Okay, Fion, is that okay? Okay. So if I want only one head, hi Sherilyn, so we just need to keep listing all the possible outcomes for each throw. Yes, yes. Okay, so you just think of each one as a separate thing. Okay, so if it helps, you can cover it up. So when you think about your first throw, okay, you can either get heads or tails, right? Then you cover up your second, oops. Okay, then you cover up this, and then what are the possible, okay, what are the possible outcomes you can get when you throw your, second coin, right? Then this is another option, right? So when I throw my second coin after my first coin, these are all my different outcomes. Okay, then, okay, yes, Denise, okay, like the different paths, different outcomes for the one time I throw my coins. Yes, okay, very, very good. Okay. Hi Fion. Oh, so only can one coin hit. So first time is hit, the rest is tail. Yes, yes. Okay, for this question. Yeah, for this question, we want only one coin is hit. Okay? So this means we want only one hit. Okay, so if this one is hit, then the rest must be tail, right? The rest must be tail. Okay, or if this one is head, then the rest must be tail. Okay, or if this one is head, if this one is head, then the rest must be tail. Okay, so we have 3 paths, okay, and each is half times half times half. Okay, so we times 3. Okay, so we get 1 out of 8 times 3. That will give us 3 out of 8. Is this clear? Anyone else has any questions? Please feel free to clarify, okay? Because this is a very important concept. Yes, okay, that's good, Charlene. Glad to hear that. Okay, so let's move on to the okay, so why times 3? Okay, because technically the proper way to do it would be to remember what I said for tree diagram. okay, we multiply along the branches, right? So for the first branch, okay, for this branch that I circled, this is half, right? Remember my probability on each branch is half. Okay, so my probability for this circle yellow branch is half times half times half. And then for the one in highlight, okay, I'll do it here. Oops, I do it like this. Okay, this is half times half times half as well. Okay, because each probability is still half, right? Okay, this is for the one in yellow highlight. And of course, for the one in green, it's also half times half times half. Okay, so if you write everything out, you will get this plus this plus this. Okay, then remember you can do factorization. Okay, think of this as your single expression of x. Okay, so you have x plus x plus x, so that is the same as 3 times half times half times half. Okay, should give you 3 times 1 over 8. Okay, but of course this 3 times thing, right, only works for this particular question. Okay, next week we will do a bit more different, okay, I would say harder, but like questions that don't have the same probability. Okay, so we won't be able to use this times 3 method. Okay, but for this particular question, we can still do it because the probabilities are the same. Yes? Any other questions? Okay, please feel free to clarify, yeah? Can I do it by counting the circles at the end that the number of H and T, sorry? Hi Denise, can I do it by counting the circles at the end that number of H and T's at the third coin? Huh? Sorry. What do you mean? Okay. What do you mean by that number of H and T's at the third coin? The number. You mean over the total number of H and T's? Um, mm, like I say, you can. So sorry. No, don't worry. Don't apologize. Okay. So for this question, yes, you can do it. So this is similar to what someone else asked earlier, right? Like why can we add everything? So it is only applicable for this question. Okay, because like I said, the probability is the same. But next week, okay, when we do questions with different probabilities at each branch, you will realize that you cannot simply add them together like that. Okay, so we don't recommend you getting the habit of adding them together because it is not, you cannot use it for other questions. It's specific to this question. Okay, any other questions? Any other things to clarify? Okay, no, then, okay, we try to do one more concept, okay? I know we are a bit tight on time. Okay, let's try, where is my play button? Okay. Okay, so with and without replacement. So again, we have our box of 20 bubbles, okay? And, okay, so we have a box of 20 bubbles all together. And in our first draw, okay, this is important, yeah, pay attention. In our first draw, we take out a red. Okay, so remember just now we learned how to calculate the probability of red, right? So what's the chance of me taking out a red in my first draw? So the probability of me taking out a red will be 5 out of 20. Okay? Okay, then I simplify to get 1 over 4. Okay? So that is my, so you realize my red, I took out a red ball, right? So so it's like I'm playing a game with my friend and I say, oh, I think what's the chance of me taking a red ball? I am talking to my friend and I have this box in front of me and it's covered, so I cannot see. And then I say, what's the chance of me taking a red ball? And then my friend tells me, oh, it's 1/4. And then I reach for a ball, and true enough, it's red. Okay, so I have taken that red ball out. So now, how many balls are inside the box? So I've already taken one red one out. So now I only have 19, right, inside the box because I have one in my hand. Okay, so now the chance of me, so this time when I talk to my friend, so I have one red ball already in my hand. Then now I talk to my friend and I say, oh, so what's the chance of me now taking a red one again? Okay, so this is my second time I'm going to reach for a red one. So you realize now I only have 4 red balls left inside. Okay, and 19 balls altogether because I already took one red one out. Okay, very good, Somansh and Sherilyn. Okay, yes, 4 out of 19. Okay, very, very well done. Okay, so because we take 5 minus 1, because there's one red one that's already out, and 20 minus 1. Okay, so that was without replacement. Okay, so without replacement means I don't replace it. English, right? Okay, but what if I replace it? Okay, with replacement means after my first draw, I took out. So I was talking to my friend and I said, oh, what's the chance of me? This is the first time, I don't have any balls in my hand. And I say, oh, what's the chance of me taking a red one? Then I reach for it and I take it out and I say, oh, it's really red. And then after I say that, this time, instead of keeping it in my hand, I put it back in. Okay, so that is with replacement. So you will see the ball, it comes out, but then it goes back in. Okay, so the total number of bubbles did not change. Okay, do you see the total number of bubbles did not change? Okay, so the probability of me taking a red the second time is still the same, right? Because the total did not change because I put it back. Right, so there are still 5 red balls and there are still 20 altogether. Yes? Okay? Is this clear? Okay, so for my first draw, when I wanted to take a red, it was 5, right? 5 out of 20. And then for my second one, if I didn't put it back, okay, it would have been 4 out of 19. But if I put the ball back, then the probability would remain the same. Okay, is this clear? Okay, the main thing I need you guys to know is that with replacement, okay, maybe I'll do it in green as well. Okay, with replacement, the probability does not change. Okay, so write this down somewhere. Okay, with replacement, the probability does not change. Okay, because I put the thing back. Whatever I took out, I put it back. So essentially, nothing changed. Okay, is that clear? Okay, so let's try a worked example. Okay, we have a few more minutes. A box contains 5 red bubbles, 7 blue, and 8 green bubbles. Okay, so a bubble is drawn from the bag at random with replacement. Okay, and then after I replace it, then I draw a second one. So display all the possible outcomes using a tree diagram. Okay, so my first draw, so I have 2 draws. So my first draw, what are my possible outcomes? So for my first draw, I can either take a red one, a blue, or a green bubble. Very good, Sherilyn. Either red, blue, or green. And what is the probability for each? Okay, the chance of me getting red will be 5 out of total. Okay, let me do the total. Total here I have 12 plus 8, 20. Okay, 5 over 20. Oh. Okay, and then this will be 7 out of 20. Okay, and green will be 8 out of 20, which will also be 2 out of 5. Right? Divide by 4, divide by 4. Yes, everyone clear with this? Okay, so now so take your hand and cover your screen. Okay, so cover blue and green. Okay, so cover blue and green. So now assuming my first one was red, what outcomes can I get when I draw my red? When I take my second one. So if my first one was red, my second one, I can either draw red, blue, or green. Okay, is this clear? Same for, okay, so use your fingers, cover red and green. So if I drew blue the first time, the second time I can still either draw red, blue, or green, right? Same for the last one. Okay, and then of course you need to fill in the probabilities. Okay, and this time since it is with replacement, okay, the probability does not change. Okay, so I have the same values. Is this clear? Okay, so let me do part B. Okay, find the probability that both bubbles are of different color. So if I drew red the first time, means my second one must either be blue or green, right? Okay, so let me list out. Maybe I'll list it out. Okay, so it's either red and then blue, or I can do red and then green. Yes? Or I can do blue and then red, or blue and then green. Everyone following? Or green and red, green and blue. Okay, then I'll need to calculate the probabilities of each. So the chance of me getting red the first time is 1/4. Blue for my second draw will be 7 out of 20. Okay, is this okay? Is everyone okay with this? Okay, very good. Okay, then I'm just filling in all the respective probabilities. Okay, so red again 1/4, green will be 2 out of 5. Okay, then I add everything together. Okay, so I list everything out. Okay, so you can type all of that into your calculator. Okay, and you should get sorry. Okay, you should get 131 out of 200. Okay? Is that clear? Any questions? Okay, can I write 1 red, 1 blue, 1 green for first? What do you mean 1 red, 1 blue, 1 green? So you put the number 1 here. Okay, it's not really recommended, okay, that you do that. It makes more sense. It might make sense to you, I guess, but that is not really the standard for a tree diagram. Um, but you can always check with your teacher and see if she will allow you to do that at the start, just for your understanding first. But as you get more used to it, okay, then maybe you can omit that. Okay? Yeah. Okay, let's try our one more bubble question, okay, before we end. So same thing, a box contains 5 red, 7 blue, and 8 green. Okay, and we are doing with replacement. Okay, so so you replace the second one, and then you want to find the probability that the second bubble drawn is red. Okay, so 2 minutes for this. Your time starts now. Okay, so draw your tree diagram and then calculate. Okay, so what's the probability that the second is red? Okay, so if you think about it, the probability that the second is red means that you can either have red the first time, red the second time, or blue the first time, red the second time, or green and then red the second time. Okay, so then calculate each of the respective probabilities. Okay, so chance of getting red the first time will be 5. Okay, 1/4. Okay, it'll be good if you can write it out somewhere also. Okay, you probably have your tree diagram lah. Okay, so probability of red is 1/4. Probability of blue will be 7 out of 20. And green will be 2 out of 5. Okay, so then you can refer to this as you fill it in. So 1/4 times 1/4, 7 out of 20 times 1/4. This one will be 2 out of 5 and 1/4. Okay, then you type all of this in to your calculator. 7, 20, 1/4, 2, 5, 1/4. Okay, so you will get 1/4. Is this okay? Clear for everyone? Okay. Okay, maybe I'll just do one more worked example before we end. Okay, the bubble question, I think I'll post it onto Genie Ask so that if you want to earn bubbles from it, you still can, but at least the solution will be provided to you as well. Okay, but of course, please, I know some of you are really hardworking and I applaud you, okay, for going onto Genie Smart, even though it's your holidays. So the rest of you, please try and do that as well. Okay, please try and go onto Genie Smart, especially since if you know that this is a new concept and you need more practice to get more familiar with it, okay, please go on to Genie Smart or Genie Ask, okay, and get more practice there. Okay, so let's try without replacement. So this time I'll spend a bit more time on my tree diagram. Okay, so again, this time I'll just use RBG, okay, to signify the different outcomes. Okay, so I need to do it 9 times. Oh, shucks. Okay, let's see if I have enough space. Okay, so I can either get red the first time, green the second time, blue, sorry, or green, right? And these are my two possible draws. Okay, and for my first draw, I already know my outcome is 5 out of 20 equals 1/4. 8 out of 20 equals 2 out of 5, sorry. Okay, and this one is simply 7 out of 20. But for my second draw, okay, if I drew red my first time, okay, my second draw, I will only have 4 out of 19. Okay, do you guys see that? Okay, and for blue, it doesn't change, right? 7, but my total changes. Instead of 20, now I have 19. Okay, and for green, I still have 8, but total I only have 19. Okay, this time, if I took out blue the first time, how many red do I have left? I still have 5 red bubbles left. Is this clear to everyone? Because I only took out blue. Okay, so I still have 5 red ones left inside. Okay, and if I took out blue the first time, means the second time that I take blue out, I only actually have 6 left in there. Okay, and of course this will be 7, this will be 8 out of 19. Okay, so do go and practice this. I highly encourage you guys to do that, please. Okay, and this will be 7 out of 19 because I took a green one out the first time. Clear? Okay, I know we are quite over time. Okay, so find the probability that both bubbles are different colors. Okay, so different colors means red, blue, green, blue, red, green, or green, red, blue. Right, then I'll add all of that together. Okay, so I want you, okay, I guess I will post this onto Genie Ask as well. Okay, so you guys can try one worked example and one bubble question. Okay, so I know, yeah, so this is the bubble question that will be posted onto Genie Ask, okay, for you guys to try as well. Okay, and we have this bonus question with 40 bubbles. Okay, so if you are still not quite familiar, okay, please go and rewatch the video, revisit the concepts. Make sure you really have a very good grasp of the difference between possibility diagram, tree diagrams, okay, how to find the individual probabilities and how to find the combined probabilities. Okay, how to use, when to times the probabilities and when to add them. Okay, you will, I highly recommend that you get more familiar with it because next week we will be building up on this topic. Okay, yes. So otherwise, I wish you guys a very happy Merry Christmas. I know after such an intense lesson, it's like Merry Christmas. Yes, but I do wish you guys a happy Merry Christmas. Okay, have lots of fun. Take care, stay safe, and yeah, I hope you enjoyed today's lesson, and I look forward to seeing you guys again next week. Okay, if you guys have any other questions, I'm sorry if I cannot stay longer, okay, to answer them, but please feel free to go on to Genie Ask, okay, and clarify them. Okay, I look forward to seeing you guys again. Take care and bye-bye.